This is the first unit for organized counting. We're going to talk about the different ways of counting. Now, this seems very simplistic and very straightforward, but there's different ways to count and things that you've learned over your lifetime. There's different ways of counting. And what we're going to try to look for are different ways to organize data so that when we talk about more complicated scenarios, we can understand them. And the idea of combinatorics is just the branch of mathematics dealing with ideas and methods for counting, particularly for complicated situations. So we're not saying that the idea of if we have a small set of solutions, it's okay to be able to say, I can count them by brute force. The idea there is I can list all the objects. But we're going to learn different ways of sorting that information as we move forward. So possible applications could look at how do we arrange our objects in a line, or how many groupings or possibilities that we put to sort people, or the different number of routes we can do that. So the first example, normally we would just get up and get into the groups, but what I want you to do is think about the ways that we can organize these letters of A, B, C, D. And what are some thinking that has to go along with this? And one of the things that we can look at is we have, in this case, we have 4 letters, and they're very distinct, right? So there's no repeating or anything like that. They're very distinct in terms of the way they look like. And one thing that you were looking at in terms of the idea of brute force is I can start figuring out some ways to organize these things. So I can say, hey, you know what? I'm going to start with A, and then I'm going to look at the other letters of how to arrange the other ones. So if I can have A, B, C, D, and then I can look at B, D, C, and D, B, C, and I can keep going, D, C, B, and C, B, D, and C, D, B. And all those are ways of counting so that the letter A starts with the letter A. And then what I can do is, all right, we'll look at the next one. So we start with B. And hopefully when you're looking at this, is the idea here is we're going to see some patterns. So here we have 6 objects when we start with letter A. And hopefully we'll see as we go forward, there's probably going to be 6 other ways to do that with starting with letter B. So B, A, C, D, B, A, D, C, and then let's put C out front. All right, and then put D out front. All right, and I could continue with that. And hopefully you would look at that there would be, as I go along, if I did the same thing with starting with C, there would be another 6 full ways. So the answer here is 24 different arrangements. MENTS. Okay? So the question now is there a pattern? Is there a way of looking at this? And one of the ways we can look at about it, another way is you can think of it as a tree diagram. And you can think of it as, here's my first letter. I could have A, B, C, D. And then I could think of it branching off of that. 1, 2, 3 different ways. So B, C, D. All right, there's a second way of placing those things. And then I can go here, there's 2, 2, 2, and I keep going with that. and my fourth place would be the same one option. So the idea there is I can almost think of it as almost kind of like a placeholder. And I can think about each place as being very distinct. So if I was looking at this first spot, you could say I can have 4 letters to start with. The second spot has 3 letters to start with, 2 letters for the third spot, and 1 spot, the last spot would be the 4th letter. And if I look at that and I multiply those, I would get the same answer of 24. So what we're going to try to look at is there is nothing wrong when we have 4 objects and we're trying to sort with the brute force. We could think of it as a tree diagram as well. Or we can talk about the idea of the steps when we put into each step. And what we're doing is, what is the easiest way of looking at it? Eventually, that's going to be the easiest way we look at that. And what this is called the fundamental counting principle. And what that means is, if you look at the number of for each spot you have, you're going to have X number or N number spots as we put forth. And we can place those numbers in. And we are going to look at those as multiplying. So this is one of the first major counting principles that makes our life a lot easier when we are determining larger sums of data when we move forward. If we turn the page, that's what we're looking at. So these are independent events that happen at the same time and are independent of each other. So the idea there is when we were putting A, B, C, and D, all right, the way we choose A and B, those are independent of each other. They don't interact and they don't change those things. And what we just wrote on the first page is exactly what this rule is. All right. So if a task is made up of stage or positions with separate choices, the total number of choices is, all right, and it doesn't have to be reducing by 1. It depends on how many objects you have moving forward. So it's the product of those choices. And I could continue that on forever. All right, depending on the choices that you make. So we can think of like that. So that's the first rule we look at that. And for most people, it will depend on how many spots can go into each stage or each position, and then you would multiply the results. So we're going to look at these quite a bit today as we move forward. So how many ways do they arrange 4 balls in a line? Well, if we were thinking about it on line, we have distinct possibilities. We can have the first spot, the second spot, the third spot, and the fourth spot, since there's 4 balls or 4 objects. And then we're going to arrange all of these. All right, so we asked ourselves, well, how many balls could fit in that first spot? The answer would be 4. The reason why this decreases by 1 is because you have 1 less ball to choose from since you've already chosen in the first spot. Same thing here. You've already chosen 2 balls. The third spot, it has 1 more less again. All right. Then we have 24 different arrangements. So very similar to the ABC that I have at the front. All right. In this example, we cannot reuse any of those. When they've already been chosen. So I can't reuse any of them because they've already been chosen, they have to be there. Sometimes we look at license plates. So if you look outside the window right now, you will see different license plates have different codes. And for the most basic cars that you see outside your window, they have a combination of 4 letters and 3 numbers. So again, there are 4 different spots for letters and 3 different spots for numbers. So the question you have to ask yourself is, how many different things can I put in each of those? How many different things can I put into there? Well, with our knowledge of the alphabet in English, we know we have 26 total letters. And we know if we have 10 total digits, so singular digits. So the idea there, I can choose 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So those are the different options I have. So that's question 1, is how many total objects I have. And the second question is, are we allowed to repeat? Well, in our society, when we look at license plates, right, we can repeat the letters because we can choose them more than once. So that means I have 26 letters for 1, 26 letters for 2, 26 letters for 3, 26 letters for 4, and times the 10 digits. Okay? This shows my communication. So this layout tells me of all the information I have. And then, in the end, I can just go to my calculator. And we know that using our calculator, there are different ways of putting that in. So I can go on my calculator, I can go 26 times 26 times 26 times 26 times 10 times 10 times 10. And of course, that's going to be a lot of license plates. 4, 5, 6, 9, 7, 6, 0, 0, 0. All right. Another way of shortening this up, and a lot of you guys have experienced this before, is the idea of if I have 4 things that are multiplying each other, I could actually decrease this to is 26 to the power 4 times 10 to the power 3. What I'm saying is, I don't care how you communicate it, but tell me what you're communicating and then tell me the answer. So in this case, there was no repeat, but you're allowed to repeat in this case. Yes, you're allowed to repeat the letters and the numbers. Okay. But if you look at the next question, there are some scenarios where repetition is not allowed. So we've put some restrictions into this. So we have to think. All right. So in this case, I'm not allowed to repeat. Well, still I have 26 letters and I have 10 digits. But here I'm not allowed. So I can still think of it as, right? I can still think of it like this. So I have 26 letters, right? Now, if I'm not allowed to repeat, that means I have 1 less letter to use. So that's where I have 25. Again, I've already used 2 letters, so that means I have 24 and 23. Digits, I start off with 10. And the next one, I only have 9 to choose. And the next one, I only have 8 to choose. So this is my kind of my communication to get to my answers from that. And I can go ahead and put that in my calculator. So I go over here, I can go 26 times 25 times 24 times 23 times 10 times 9 times 8. And hopefully when I do this, that it's definitely less than this one, because if we repeat, we should have more options. All right. So this fundamental counting principle works when you have repetition allowed or non-repetition allowed. You have to be able to think and read the question. All right. So I can look at this. A company makes gloves that are black, brown, gray, and burgundy. Each of the 4 colors is made available in small, medium, large size. How many different types? Well, I can still sort this thinking. I can think about, I've got black, brown, gray, and burgundy. And I have 3 different types. I can have small, medium, and large. Well, I'm allowed to have those 3 of those kind. So if I look at that, that's either 3 to the power 4 or 81 different types. All right, because I have small, medium, large for each time, I can plug those in. That's what we're looking at. We do not have to list all of them. All right, we just want to know how many we have. Okay. So what I would like you to do is push pause, see if you can try question 2 on your own, and then come back and we will talk about how you get that in. So hopefully when you were looking at this, you made the decision that there was 6 people in 6 spots, all right? And we can't repeat people. So we can't have the same person in 2 different spots. So when we're looking at that is we put as many people in the first spot, and then it reduces by 1 each time. And then from there I can get my answer. So I can go 6 times 5 times 4 times 3 times 2 times 1. So I can just type that in the calculator. All right. So I get that. Now, for some people, you may have seen this before, how to shorten this up. We will show you that in the next lesson of how to shorten this thinking up using our calculator, but at this time we're not going to talk about that. But if you know how to do it, great. Well, last idea we're going to talk about is mutually exclusive. So events that cannot happen at the same time. So the idea there is this idea of rule of sum. All right, so if one event is mutually exclusive and occurs m ways and n ways and p ways, what we end up doing is adding those results. Now, you're going to ask yourself, well, where does this come into play? And the word or is becoming it will become very important. So the idea there is I can roll, so let's say if I can, the idea of saying if I was going to roll a sum of 10 or a sum of 12. The idea of that is these cannot happen at the same time. Either you roll a sum of 10 or you roll a sum of 12. You can't do both at the same time. And you're going to see that with some examples as we move forward. But that doesn't mean that we might have to do some multiplication as well. All right. So the first example here is how How many ways to roll a sum of 4 or sum of 10? Well, there's that idea of or, that means we need to add. So, all right, so this chart here is a chart that you will always have access to, and these shows you the number of sums of 2 dice. So the idea here is 2 plus 1 gets you 3, 2 plus 3 gets you 5, and these tell you all the different sums. So if I look at that, here I have 3 sums of 4, and 3 sums of 10. That means I have 10 sums of 4 or 10. Okay? So that's the idea of that, and we're going to be applying these ideas through a lot of these. So, how many ways to arrange 5 or 6 people? Well, we're going to arrange 5 or 6 people in a line. All right, arrange 5 or arrange 6, and we know we're going to add those up. But here's the other thing. If we're going to arrange them in a line, all right, my fundamental principle counting is still going to happen here. So here I have 5 people, 5 spots. All right, I'm going to be multiplying those numbers. All right, so the counting principle that we talked about at the beginning can be used in conjunction with with OR as well. All right, I got 120, and since we're arranging people, I can't repeat the people. All right, I can get that. All right, so the idea there is the word OR means I look at each 2 events, get the count for each of them, and I can add them up at the end. All right. So what I would like you to do is, using the same thinking that you did for question 2, what would be for the answer for question 3? All right. And here I have 8 different balls, and I want to arrange into groups of 4 or 6 in a line. So what I'm going to do is I'm going to hit pause. I want you to try some of the thinking, and then we'll come back. So hit pause, give it a go. So one thing I can think about is, I have a couple things is, I have to figure out how many total balls I'm using. So we have 8 objects, all right? And then we have to decide how they are arranged. And this idea of OR means I have to look at those separately. So when I was looking at this, hopefully you decide that to make 4 spots, and then I can put in the total number of balls I choose from and subtract 1 because I can't repeat them. Same thing with the 6. I know I have 8 total balls, and I'm going to arrange 6. So I start with 8, and then 7, and then 6. And I know that that's multiplying because that event is happening at the same time. And then I can get those answers and add those up. All right. So in that case, there was 42,000 different ways arranging 8 balls in a line of 4 or 6. So the thinking to set up the question is really important. So a couple other things to think about. Do you use the rule of product or the rule of sum for this? Well, here I'm rolling a sum of 4 or 7. Hopefully that is sum. The reason? The word OR. Selecting a dress, hat, and purse to wear at a wedding. Well, I'm hoping that's product. The word and's being used. So hopefully if you were going to a wedding, you do have a dress, and a hat, and a purse. It would look kind of weird if you only had a dress and not a hat or a purse. Or just a hat and not a dress or a purse. I'll let you guys think about that for a second. Picking a horse in either the first or the second race. Hopefully you would say some. Making a sandwich with ham or salami, hot or sweet mustard on white or whole wheat. You actually would use some or and product, because you need to add up. There's two options there, so I would add that, and add that, but then I would want to multiply the results for that. Okay, so hopefully that takes away from the lesson, and you can, the idea there is you can split up mutually exclusive events, so solve them separately and then add. If you have specific positions, draw out the boxes or lines to illustrate it. Fill in those positions with how many objects can be placed there. And you have to kind of watch out if you're allowed to repeat objects. People can't be repeated. Give that a question to go, and we will talk soon.